Dear students, we are discussing today measurements and experimentation. That is the first chapter of class 9. Here, we have to learn about how we can able to measure some physical quantities. What is physical quantities? See, the quantities which can be measured, anything which can be measured, that is a physical quantity. Example, we can able to measure the mass of a body, the length of a body. We can measure temperature, we can measure time. All these quantities are known as physical quantity. But the things which cannot be measured, like sorrow, joy, okay, grief, these are not a physical quantity. Okay, so physical quantity means which can be measured by any direct or indirect process. Okay, coming to the next point, how we can able to measure it. So when we are talking about measurement, measurement is nothing but a comparison between a physical quantity with a standard quantity of same kind of physical quantity or standard value of same kind of physical quantity. That is known as measuring or measurement. So measurement is nothing but comparison. Assume 1 meter rod is given to you and it is told to you to measure a long rod which is more than 1 meter. So what we have to do, you have to start from the starting point and repeat the 1 meter rod you have, and you have to go till end. If you have seen that it will take 10 times of your rod, okay, your 1 meter rod, to complete the whole long rod, so we can say that the measurement of that long rod will be 10 into 1 meter, that is 10 meter. And that is been explained in the next part, that is unit. So unit is that standard quantity what we are using to measure something. Here I have used the 1 meter rod, so 1 meter rod is my unit. Just like for any other physical quantity, any standard value should be taken as its unit. So how we can able to represent a physical quantity? So to represent a physical quantity, you see the physical quantity represented by the numerical value into the unit. So numerical value, if I am given the previous example there, 10 is the numerical value and your unit is 1 meter or meter there. So by that, the value of that physical quantity is 10 meter. Okay, so by this way, we can able to measure a physical quantity. Coming to the next part, when we are talking about the standard quantity or unit, how it can be differed. The unit can be divided into two types. It is written here. One is fundamental or basic unit, and another one is known as derived units. What is fundamental or basic units? The fundamental or basic units are those which doesn't need any help of any another unit to represent it. These are known as fundamental units, just like mass, just like length, time. So to represent this unit, we don't need any help of any other unit. So we don't need a help of a unit of length to measure the mass. We don't need a help of a unit of time to measure the length. So that's why these are known as fundamental units. Which one is derived units? The units which is being measured by using two or more than two physical quantities. Just like if I'm talking about speed of a body, velocity of a body. So you know speed is meter per second, velocity it is also meter per second. So here the unit of length and unit of time both are needed to represent it. So unit of speed or unit of velocity, it is a derived unit. So coming to the next point, how many units or how many unit systems we have seen around ourselves? There are three kind of unit system generally used based on three basic fundamental units, that is length, mass and time. Okay, so the three unit systems that also you have learned earlier, one is known as CGS, another is MKS and another one is FPS. So CGS, this how this unit system has come. This is a French unit system where C stands for centimeter, that is the unit of length. G stands for gram, that is the unit of mass, and S stands for second, the unit of time. Similarly, MKS, it is a Latin unit system where M stands for meter, unit of length, K stands for kilogram, which is a unit of mass, and S stands for second, which is a unit of time. And FPS, which is known as a British system, okay, where F stands for length, feet, and M stands for pound, that is mass, and S stands for second, that is for time. So these three general unit systems we have used earlier, but later on, when more fundamental physical quantities are discovered, after that, some another physical quantities are also introduced as a fundamental quantity, and their units are taken as fundamental units. For that reason, one international system has been introduced to measure the physical quantities, and this international system, or the Latin name is Systemi Internationally, that is the SI unit. And it is written what is SI unit. So SI unit is Systemi Internationally, that is the international system. Here you see, along with length, mass, and time, we have taken four more physical quantities, which are basically taken as the fundamental quantities. So total fundamental quantities is taken here, it is 7. So it is length, its unit is meter, symbol is M, mass, unit is kilogram, and symbol is kg, time, second, electric current, ampere, whose symbol is A, thermodynamic temperature or temperature, whose SI unit is Kelvin, which is denoted by capital K, amount of substance is mole, which is denoted by MOL, and luminous intensity, which is denoted by candela, that is CD. Okay, so these are basic 7 fundamental units, and using that units we can able to form some derived units. Now we have to come the basic physical quantity, the basic fundamental quantity, that is length. So we all know that we have discussed earlier that the unit of length is meter. So now the question has come, what should be the standard value of meter? How we can able to know that? And for that reason, I have written here two definitions. You see, first definition tells us a meter was originally defined 1889 as the distance between two marks drawn on a platinum iridium rod kept at 0 degrees centigrade in the International Bureau of Weights and Measures at Sivers near Paris. So a rod, okay, 2 point in that rod at 0 degrees centigrade, that is been taken as the standard value, which is 1 meter. But later on, this definition is modified, and that is told the meter is the basic unit of length. In the SI system of units, the meter is defined to be the distance light travels through vacuum in exactly 1 by 29 crore 97 lakhs 92,458 seconds. We all know that light travels 3 into 10 to the power 8 meter in 1 second. So how much distance will travel in 1 meter? That will be 1 by 3 into 10 to the power 8 second. So the 3 into 10 to the power 8, its exact value will be 29 crore 97 lakh 92,458 seconds. So that is the definitions of meter. Any one definition you have to read and memorize. Okay, next, where we have to discuss some bigger and smaller units. Okay, because if I'm talking about the general units that you know, that is meter, you all know centimeter, millimeter, that is the metric system that we know, that we have learned from class 5 only. So here we are not very much interested about that. We are interested about the bigger units and smaller units which we generally not use. Okay, that is not in our metric system. The bigger units, first one is astronomical unit, that is AU. What is AU? AU is the average distance between Earth and Sun. It is the average distance between Earth and Sun, and that is taken as a unit. And 1 AU is equals to 1.496 into 10 to the power 11 meter, or sometimes it is told 1.5 into 10 to the power 11 meter, that is equals to 1 astronomical unit. Next one is very common, that is light year. So the light travels in 1 year. 1 earth year means the year is calculated by us, that is 365 days. So light travels in 365 days. How much distance? That will be 1 light year. So 1 light year equals to speed of light into 1 year. Okay, the value will come, it is 9.46 into 10 to the power 15 meter. Assume the distance, how long it is. In 1 second, light can travel 3 into 10 to the power 8 meter per into 10 to the power 8 meter, where we are talking about the time in 1 year. So we have to calculate in 1 year how much seconds are there, and we have to multiply it with 3 into 10 to the power 8, and then we'll get this value, that is 9.46 into 10 to the power 15 meter. Another unit that is also a bigger unit, that is known as parsec. Parsec is the distance from where the semi-major axis of the orbit of Earth subtends an angle of 1 second. What is semi-major axis? I'm little bit clearing you out. See, we all know the Earth is revolving around the Sun in elliptical path. Okay, as it is moving in elliptical path, so the longer distance is taken as semi-major axis from Earth to Sun, and that one subtends an angle in 1 second, that is known as 1 parsec, and 1 parsec equals to 3.26 light year. The values I have written here, these are very much important. You have to remember it, otherwise there is no method to make you clear. Okay, you have to remember it. Now we are coming to the smaller unit. Smaller unit means if I want to measure the subatomic particles, then what units we have to take? First one, the length. If I want to measure the length of the distance between the stars, the distance between the planets, there we have to use these bigger units. But if we just want to find out the dimension of subatomic particles, there generally we have used angstrom. Angstrom is generally used to measure the size of an atom, and 1 angstrom equals to 10 to the power minus 10 meter. Nanometer, here we want to show you, want to represent the smaller particle. Now you know the nanoparticles. So these nanoparticles nowadays its use is very large. Okay, so it is also the measurement or unit by which we can able to measure the size of the subatomic particles. Not only that, we can measure the wavelength of visible light also by this unit. So 1 nanometer equals to 10 to the power minus 9 meter. Similarly, 1 micron equals to 10 to the power minus 6 meter, and 1 Fermi. This unit is used to measure the size of a nucleus. We all know the atom is formed by nucleus and electron. To find the size of the nucleus, we generally use the unit Fermi, that is 10 to the power minus 15 meter. Okay, so that is the calculation of length, and the units of length generally we have used. Now we'll go to the next part, where we have to find out another physical quantity, that is mass. Okay, so mass can be calculated by its SI unit kg. So how this SI unit kg is being defined? So the kg is being defined by an international prototype made in platinum iridium and kept at International Bureau of Weights and Measures. So it is also a rod, you can say, a substance which is made by platinum iridium and which is kept in International Bureau of Weights and Measures. Its mass has been taken as the standard value of 1 kg. Okay, so what is the relation of this SI unit with another unit that we have seen? 1 gram equals to 10 to the power minus 3 kg, 1 milligram equals to 10 to the power minus 6 kg, 1 quintal, that also you know, 100 kg, 1 metric ton, 1000 kg, 1 AMU, that is the unit of mass which is mainly used to measure the mass of subatomic particles, the smaller particle. It is 1.66 into 10 to the power minus 27 kg. And why it is symbolized, how it has been found, it is already written. The atomic mass unit is defined concisely 1 by 12th of the mass of an carbon 12. We know there are isotopes of carbon. So one isotope is carbon 12, that is C12. So 1 by 12th of the mass of carbon 12 atom is your 1 AMU, that is atomic mass unit. Another one is solar mass. Solar mass is basically the mass of sun, and that is been taken as 2 into 10 to the power 30 kg. And by this unit we can able to measure the bigger substance, the astronomical substances. Okay. Coming to the next part, that is time. Okay, so we all know the SI unit of time is second. Okay, so how this time second is being defined? So it is written here, 1 second is the time that elapses during 91926317770 cycles of radiation produced by the transition between two levels of cesium-133 atom. So cesium-133, it is a radiative substance. So transition between two levels means when it is coming from the higher nuclear level to lower nuclear level, there it radiates some energy, and due to the radiation some pulses will come, and 1 second is the time that elapses during 91926317770 cycles of radiation produced by the transition. Okay, or another way also you can define 1 second. 1 second is equals to 1 by 86,400 of mean solar day. 86,400 of mean solar day. Solar day means to complete 1 day. So in 1 day, how much second is there? We know in 1 day means 24 hours. 24 hours means it is 86400 second, means 86,400 second. So 1 second is basically equal to 1 by 86,400 of mean solar day. Okay. Now here also we have just written some relation, that is 1 minute equals to 60 second, 1 hour equals to 3600, 1 day we have just told 86,400. Another unit of time is lunar month. Lunar month means the time when the sun can able to complete one round around the earth. Many calendars are there, Bikram Shangita or Hijri calendar by the Muslims. There, this lunar month is followed. Okay, we know for different religion they are having different calendars are there, they have to follow that. So one lunar month is equals to 29.5 days, and 12 lunar month equals to 354.37 days. It is nearer to 365. Okay, but not exact. So we can say that it is not an exact value of time calculation, but earlier when the people is not having any watch, okay, any calendar, usually they have found the cycle of moon, and by which they can able to measure the month. 1 year, we all know it is 365 days. 1 year equals to 3.1536 into 10 to the power 7 second. If it is talking about leap year, we all know, so the time, the year we are now, that is 2020, it is a leap year where 366 days. 1 decade equals to 10 years, 1 century equals to 100 years, 1 millennium equals to 1000 years. So these are the unit of time. So here we have discussed about the unit of length, unit of mass, and unit of time. Next, we have to show you some example of derived quantities. Okay, basically the previous portion is discussed about the fundamental units, and here we want to show you some derived quantities. So its area, that is length into width, that you all know, and that chart, if you see that these quantities, that is area, volume, frequency, density, here to represent it, some another physical quantities are responsible. Okay, see, if I'm talking about the symbol here, you see meter square, meter cube, second inverse, kg per meter cube, meter per second square. Here, two or more than two physical quantities units are needed to represent that unit. So that's why we can say that these are derived units. Okay, so the basic idea of derived units, it is given to you. So my suggestion is that read the chart. I think you can able to understand. Okay, next we'll go to the experimentation part. So in experimentation part, we'll start it from measurement of length. So before experimentation, we need to learn something, and that one is least count to measure the length. What is least count? The definition is written. The least count of an instrument is the smallest measurement that can be taken accurately with it. Here you see two scales are shown to you. One is ruler number 1. You see it is written 1, 2, 3, 4. So we can say that its least count will be 1 centimeter. And coming to the next ruler, you see in 1 centimeter there are 10 more lines are there. Means we have divide 1 centimeter into 10 part. Okay, so that's why each of the division, it can measure zero point 0.1 centimeter. So for the first ruler, the least count is 1 centimeter, and second ruler, the least count is zero point 0.1 centimeter, and it is told that whose least count is less, by that scale we can able to measure accurately. It is very much clear to you. By the second ruler, we can easily measure a object, the length of the object accurately, which cannot be done in the first ruler. Okay, coming to the next part. Assume if you want to measure the length of an object, and that time that one is completed. Just see my mouse pointer here. It is completed crossing 2 and coming here and ended at this point. It is 1, 2, 3, 4 and 5. It is 2.5 and this is 2.6. Just see my mouse pointer, 2.5 and 2.6. If the object is ended in between this point here, so which value we have to take in? It is already crossed 2.5, but it is not reached 2.6. So whether it will be 2.5 or 2.6, the length of the object. To calculate it accurately, we have taken one another scale, that is known as vernier scale. So the basic reason to take another scale, that is named as vernier, to measure something accurately, because if some object we measure and if it cross one division and it cannot able to reach another division, it will end at middle, then how we can able to measure the exact length, and that's why it is taken. So if I'm talking about vernier scale, how the vernier scale is arranged. You see here it is written vernier scale and at top it is written main scale. So vernier scale and main scale are aligned with each other. So to measure accurately with the main scale, means the scale we have generally used, this scale. Okay, see my mouse pointer, and along with the main scale, the vernier scale is being taken. You see the number of divisions in vernier scale here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 vernier scale divisions are there, and it is aligned with main scale. Acha, how many divisions in main scale are there? It is 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 9 main scale division is just aligned with 10 vernier scale division. So it is clear that the divisions in vernier scale, it is smaller than the main scale. And by this we have to define one thing which is known as vernier constant. What is vernier constant? It is written here. Vernier constant is defined as the difference between the value of one main scale division and one vernier scale division. One main scale division, you see my mouse pointer here. So this is one main scale division from 0 to 1, this length, and one vernier scale division is this. So their difference, a very small thing, that is known as vernier constant or least count of vernier calipers. Okay, least count of vernier calipers. Now we'll ask from where these calipers are coming. It is coming by the next slide. You will be understand. So how we can able to find the value of vernier constant? Let's see. If assume here we have seen that 9 vernier scale division is aligned with 10 main scale division. Okay, so here instead of 9 and 10 we have taken n and n minus 1. So we can say n vernier scale division is equal to n minus 1 main scale division. Okay, you have write down here 10 and write down here 10 minus 1, that is 9. That calculation is also shown here, so I don't think it should be very much tougher for you. Now vernier constant will be how much? 1 main scale division minus 1 vernier scale division. 1 main scale division is 1 and 1 vernier scale division is equals to n minus 1 by n main scale division that we have calculated. Just minus it, you will get 1 by n main scale division. 1 by n main scale division. So 1 main scale division is how much? It is generally for a scale, it is 1 millimeter or 0.1 centimeter. 1 millimeter or 0.1 centimeter divided by n means divided by 10 as per this scale. So it is 1 by 10, that is 0.1 millimeter or 0.01 centimeter. It is also shown here that vernier constant equals to just like the same thing, 1 main scale division minus n minus 1 by n. So n minus 1 means how much? 9, and n equals to 10, vernier scale division, minus it, you will get 0.1 millimeter. So 0.1 is the vernier constant, or it is the least count of vernier scale. Okay, so the use of vernier scale to make a reading more accurate. Okay, going to the next slide where we can able to use the vernier scale. In next slide we will see the vernier scale is used in one instrument. The diagram is given here, that is known as vernier calipers. See, this instrument is known as vernier calipers, where this white portion, the scale you can able to see, that is known as the main scale, and the red portion or the pink portion you have seen here, that one is your vernier scale. And number of division in vernier scale, you see it is 10. That means with the like the previous one, the 9 main scale division is aligned with 10 vernier scale division, so its vernier constant will be 0.1 millimeter, that we have shown here. Now we'll just learn about the instrument little bit. So here this portion, this is the ball. If I want to find the diameter of the ball, then these two things, these are known as jaw. It is known as fixed jaw, it is fixed, and this can be movable. How it can be moved? So here you see a screw. If you press the screw, then this portion, this pink portion, it can be stretched. Okay, so this is outside jaws. By outside jaws, you can able to find the diameter of the ball, the diameter of a pipe, okay, the diameter of any object you can able to measure. Okay, inside jaws, these are known as inside jaws. Assume if I want to measure a hollow cylinder, just like the inner diameter of a bottle, inner diameter of a pipe, how we can able to measure it. So as it is stretched, so this jaw can able to stretch. So by that we can able to measure it. Next one, stripe. Number 3, this portion. So as this screw is being pressed and stretched towards the end, there is a smaller rod that is being extended. Okay, that is being coming outside. What is the main utility of the rod? The main utility is to measuring the depth. If you want to measure the depth of a glass, if you want to measure the depth of a bottle, generally it is a smaller bottle, okay, then you can able to use the stripe. Main scale that we have seen, vernier scale that also we can see. Now the question has come, how we can able to measure it? By this vernier calipers, how we have to measure the length. See, whenever it is been stretched, this vernier scale, it is moving continuously. We have to take a main scale reading. How we can able to take? See, here is the zero of the vernier scale. We will see on which point the zero of vernier scale is aligned with main scale. That should be the value of main scale or main scale reading. If I see the diagram, you see this one, this is 2, and this one, it is definitely 1.5, and here you see the next one, it is 1.4. See, the 0 is coming nearer to 1.4 but not exactly aligned with 1.4. That means the 0 is crossing 1.3 but not collide with 1.4. So we can say the main scale reading, it is 1.3. That is the main scale reading, 1.3. Okay. If I am talking about the vernier scale reading here, so for vernier reading, what we have to take? Now we have to see from 0 to 10 which one is exactly aligned with any of the main scale reading, any of them. This 0 to 10, you see 0 to 10, 10 lines are there. Which line is exactly aligned with the main scale? You see this line. Okay, this is, I think it is 8. So 5, 6, 7, 8. So 8, you see, it is exactly aligned with the main scale reading, any one of the main scale reading. So the value of vernier will be 8. Okay, so this vernier division, just see my mouse pointer, this vernier division will be 8. And then along with 8 we have to multiply the least count, then we'll get the vernier reading. What is our least count? Our least count we have calculated earlier, that is 0.1 millimeter. 0.1 millimeter means 0.01 centimeter. Okay, and now the reading, you see the main scale reading is 1.3, vernier division is 8 into the least count 0.01, and the total reading will be 1.38 centimeter. That is the exact reading. But in general, if you see in naked eye, then you can tell that it is at almost 1.4. So we will not go by that almost. We will just take the exact value, and the exact value is coming 1.38. Clear? I think it is clear enough. Coming to the error portion. See, any of the instrument It is not out of the error. There must have some error. If you use an instrument for a long time, then must be there is some error has come. And here this error is known as zero error. What is zero error? See, if you see these two jaws, just see my mouse pointer. One is fixed, another one is movable jaw. If this object, this ball is not here, and this jaw, this movable jaw is just touched with the fixed jaw, then we can say that the zero of vernier scale should be aligned with the zero of main scale if these two jaws are touching together. But if you use that instrument for a long time, what will happen, whenever you have taken these two jaw together, then these zeros are not touching with each other. There may be some gap. Maybe the vernier zero is crossing the main scale zero, or it cannot able to come to the main scale zero. This type of error is known as zero error. Okay, how many types of zero errors are there? There are two kind of zero errors are here. One is positive zero error. Here I have shown you. See, the top one is main scale zero, and the next one is coming, that is vernier scale zero. You see, it is not able to come to the main scale. That means it is left from the main scale zero. The vernier scale zero is left from main scale zero. Okay, in left side. That type of error is known as positive error when the vernier scale zero in left hand side. If it is crossing the main scale zero, here you see my mouse pointer, it is crossing the main scale zero and it is coming at right, and that one right of I'm sorry, here it is right, the first case, and here it is at left of main scale. That one is negative zero error. So if it cannot able to cross, it is short, then it is positive zero error, and when it crosses, it is negative zero error. The calculation is not important for your syllabus. Here you have to learn about what is zero error and what is positive zero error and what is negative zero error. Okay, I think it is clear enough. Next, the another instrument which is used to measure the smaller lengths, that is screw gauge. Okay, what is a screw gauge? The screw gauge, you see the instrument has been shown you. Here is thimble, this thimble, when it's rotate, then this spindle will just come closer to this anvil. Okay, just follow my mouse. That is the instrument. So I'm coming to the instrument little bit, but here you see, here is a use of screw, and that's why first we have to learn what is pitch. Pitch. What is pitch? So pitch of a screw gauge is defined as the distance moved by a spindle per revolution. Okay, measured moving in the head scale over a pitch scale in order to complete a full rotation. What is it? You see, here we are talking about this thimble. In thimble, there are some scaling you have seen. There is 5, 10, 15, 20. These scales are known as circular scale. Okay, so when this circular scale rotates, so it is basically a screw. So when it rotates, it will, if you rotate it in clockwise direction, it will come closer. Okay, and when it will rotate anti-clockwise, it moves far. So for a complete rotation, how much it will come forward or move backward, that can be measured by this main scale value, right? And that value is known as pitch of the screw. In generally, the pitch of the screw for a screw gauge is 1 millimeter. This scaling you have shown here. Okay, just follow my pointer. Here the scaling is in millimeter range. So if you take a complete rotation of this screw, then it will move further by 1 millimeter, or if you take anti-clockwise rotation, it goes backward by 1 millimeter. Okay, and where the main scale is being painted, that is known as sleeve. Whenever it is rotate in clockwise direction, this spindle, it is a rod, it is coming closer, and this rod is anvil. In this point we have kept one object. Assume, I think those who know cycle, one smaller ball has come inside the cycle, that is the ball bearing of a cycle. If anybody told you to measure the diameter of that ball bearing, there you have to use the screw gauge. Okay, so I have already told the pitch of the screw is 1 millimeter. And now one more thing we have to calculate. What is it? See, the main scale reading we have got, that is in millimeter. So the least count is 1 millimeter. But if I want to find out the least count of the circular scale, here no scaling, no millimeter or something like that. How can we have to find out? So here least count means least count of the circular scale. So least count of screw gauge is defined the distance moved by the tip turned when the through one division of the head scale. Head scale means main scale. That means least count means to complete one rotation means here in circular scale the number of divisions in generally it is 100. So to complete 100 rotations you are displaced by 1 millimeter in forward direction, okay, or backward direction. That means for 100 rotation you have gone 1 millimeter. For one rotation, for one division, it will be 1 millimeter by 100. That is known as least count of screw gauge, and it is 0.01 millimeter. Okay, that is the least count. I have given you definitions here because these are important. How you can able to measure the reading here, it is not important for you. Simply this the presentation I have made here, this presentation are made just like as your notes as per your syllabus. Okay, if you read this presentation only, you can get whatever there in your syllabus. So the numericals from this slide, vernier calipers or screw gauge, that will never come. It is not in your syllabus. So if I'm discussing the part, okay, so ratchet, you see the last portion is ratchet. It is basically the screw turning, just like the screw you have rotate to tight anything. Sleeve, where the main scale is being painted. Thimble, by which you can hold and rotate it. Main scale, here you have seen it is painted here, and circular scale or rotating scale, it is given here. And least count means here we have to find out the least count of circular scale, nothing else. Okay, coming to the next part. Here also we are talking about the zero error. What is zero error? So to learn it, we'll go the previous diagram again. If you see the spindle is exactly touching with the anvil, the spindle exactly touching the anvil, mean there is no gap, D is there, then the zero of main scale should align with the zero of circular scale or rotating scale. But if you use it for a long time, then this one is not occurred. Just you see in the diagram here, if I have told no zero error, so you see the zero of circular scale is just aligned with zero of main scale. But sometime due to the various use, it shouldn't align like this way. That's why two type of zero errors are coming. One is known as positive zero error. So when it is just below the main scale zero, you see this zero, the zero of circular scale division, which is not coincide, and it is little bit downward or below of the main scale, that is known as positive zero error. That means it cannot able to reach here, and after reaching, if it crosses, you see here it will reach and cross it, it is known as negative zero error. So two type of zero errors by the diagram you can able to understand, and here the definitions are also written. If it is below the main scale zero, then it is positive zero error. If it is crossing the main scale zero, that is negative zero error. Apart from this also, another error is occurred in screw gauge, that is known as backlash error. Why this backlash error is occurred? Because of long use of this screw gauge, you know, it is a screw, so you are continuously tightening it and losing it, so due to wear and tear, okay, sometime the spindle, okay, so when we have seen in the previous diagram, the spindle is not going in a straight way to the anvil. When you rotate the thimble, the spindle is also moving like this way, that you know, if you use it for a long time, it will not go by straight way due to wear and tear, and that type of error is known as backlash error. Okay, so how we can resolve this error? So here it is told to avoid rotating screw gauge vigorously, means don't use it vigorously, use very politely, gently, okay, to prevent the backlash error. And not only that, you have to rotate in one direction. As you, if you are rotating in clockwise direction, you have to rotate in clockwise. If it's need to rotate in anti-clockwise direction, then you have to stop for a certain time, then you go, means the direction will be confirm, and it will be very gently and slowly, then only we can get rid of this backlash error. Okay, so that is all about your screw gauge. Coming to the last part of this chapter, that is measurement of time by simple pendulum. Simple pendulum, you all know, if a mass is hanged by a massless string and it is moving continuously, the diagram is given, though it is written here it is rod, generally instead of rod we have taken thread here. Okay, here it is taken a very thin rod, so we are using mainly thread. So if you leave it here, it will just move, it will just oscillate in this position. So by that we can able to measure the time period. It is known that the time period of oscillation is directly proportional to the square root of length of this thread or rod, okay, and inversely proportional to the square root of acceleration due to gravity. So acceleration due to gravity, that you have learned in the next chapter, that due to the force of gravitation by the earth, one acceleration is produced in a body, that is known as acceleration due to gravity. If I want to find the time period of oscillation of a simple pendulum, it will come t equals to 2 pi root over of L by G. And from this equation, we can able to find out the value of gravitational acceleration. You see, G equals to 4 pi square L by T square. That means if you know the L, if you know the time period, then you can able to find the gravitational acceleration of Earth. That is, and practical you have to do in class 11. However, we are not going on that practical portion. We have to remember this equation, T equals to 2 pi root over of L by G, where length, L equals to length of the thread, G is gravitational acceleration of Earth, and T, that is the time period. And as we are talking about time period, we can able to find the frequency also. Frequency is inversely proportional to the time period, so F equals to 1 by T. So if I find out the time period, we can able to find the frequency of oscillation also, that finding 1 by time period. Okay, in your book you see many more detailing things are there, but I don't think it is needed to be learned. But my suggestion, you will go through the book, learn everything, but take it as if notes. Before exam you will just check it, and that much is important for your exam portion. One numerical I have shown here. So the numerical tells us the period of oscillation in simple pendulum, it is 1.2 second. That means the time period is given to you. The value of G is 9.8 meter per second square. So G is also given. How long the bob belong to the rigid point? You have to find the L. Okay, so it can be denoted by small l or capital L. So here the equation is written, T equals to 2 pi root over of L by G, making square, so T square equals to 4 pi square into L by G, and here L equals to G T square by 4 pi square. So putting the value, T is 1.2, it is given, G is 9.8, 4 and pi is 22 by 7 or 3.142, and here L is coming 0.36 meter or 36 centimeter. So that type of numericals are there both in your example as well as in exercise. My suggestion is that those who are looking at the video, Please go through the book, do all the numericals given in example as well as in exercise questions. I think it is enough because the numerical can come from there. Okay, the numerical can come from here, but no numerical is coming from screw gauge or vernier calipers. So be careful about that. Okay, thank you very much and hope that videos are very much helpful for you.